In this video, we're going to look into how shadow deployment works. Shadow deployment is when you run a new AI model alongside your current production model to see which one is performing the best. Now, how does it really work? Essentially, let's say you have a client which accepts some sort of request. It can be a text, number, whichever. You have a production model which gives this user an output. This production model can be any type of machine learning, statistical model, or even a deep learning generative AI model. And a company is probably getting used to this type of outputs and the user is expecting that. But if you have a new model, which is very common, you always want to improve on what you existingly have. You have a new model, you want to see how does it actually perform compared to what we have previously. So what you do is you also feed in that exact client request and check whether or not if it's working equally as good, if not better. And you compare that to see how it's working efficiently. So what is the benefits of this? The main benefit is that there's zero user impact while testing your new model. You're testing your new model based upon real traffic validation. So when you're probably building the model, you have some test set where you're getting 80%, 90%, 95%. But what does it really mean? Does it actually improve the model? Performance benchmarking, again, goes together with real traffic validation. Early issue detection. This helps us to know whether or not a model is actually doing very well. And it makes it a very smooth transition to see, okay, if this model is performing better, then we can easily redeploy it as our production model. And there we go. Now, before I go into some pros and cons and some negatives about this thing, let's see some other interesting use cases of this shadow deployment strategy. So one of the biggest benefits of shadow deployment strategies is risk mitigation. When you're deploying a brand new trained model, you don't entirely know how it's going to work with the users. Sure, you probably got 95% accuracy, F1 score, whichever metric you built. You don't actually know if it's going to work really well in production. And that's very crucial to know. In this way, you're able to identify if something happens, whether it's performance, bugs, or any other testing, and you can rectify it before it actually hits the production environment. This is super important. And also, this is a great way to do some real-world testing. The best test is going on production. So that's the great way to test a new model under real-world environment without actually hampering your current existing model outputs, which could be better. You never know. And also, I found this really nice article over here. They're saying that you can also efficiently scale. I'm not entirely sure, but maybe you can scale by seeing how well it's scaling in the environment. But again, a bit of a wishy-washy benefit in this article. But nevertheless, some use cases could be testing in a real-world scenario, of course, performance testing, application migration. When migrating from one application to another, you want to check whether or not it's impacting the user or not. So this shadow deployment strategy is a great way to do that. Now, what are some best practices? Some best practices is isolate real and shadow systems. So real systems are deployed in one way, it's affecting the users currently. And the shadow system is also gathering information from both the user and the existing model to see which one is best suited. This also requires you as an engineer to set a real clear duration and criteria. When you're shadow deploying, you have to take into consideration the cost of it. When you're deploying a model, this is going to take network and server cost. How is this affecting your business needs? And also, is it going to affect your runway cost? So that's super important. So making sure you have a clear start and end date to get the most amount of information. And also setting up traffic duplication. You have to do some engineering on how you can do it in the best way possible. But most crucially, it is very important that you're getting the feedback from the shadow model, the user, and the existing model, where you can get all the data, make it standardized in a way that you can get the metrics you need to, again, retrain the model if needed, or get the exact insight that helps you deploy your new model. Now, what are some cons of shadow deployment? This is probably obvious, but this will double your compute costs. It can probably force you to build a complex infrastructure, which can easily happen. You can have data or latency overhead, data management burden. You have to manage all the data, make sure how you can gather the information, analyze the new data, and also no real user feedback. The model cannot get direct feedback from the user. For example, let's say in ChatGPT, you can have a thumbs up and thumbs down button. This is something you cannot get with this shadow deployment strategy. So that's one real downside of this. But nevertheless, In my opinion, the benefits kind of outweighs the cons because it will not ruin your reputation when you're deploying it for a company. But it is very good to know regardless. And there you go. This was a quick rundown of how shadow deployment works in AI. I hope you found this video insightful. If you guys did, please free subscribe. I make similar videos like these. Alright guys, I hope to see you in my next video. Have a nice day.